So continuously compound interest. That means that we are using E as our base. It's okay. E is a number. E is a value. Okay. Just like pi, E has weight, numerical weight. It's not just a letter or a variable with no purpose. Okay. So continuously compound. That means every second, every minute, every hour, what you're doing is earning interest, okay, or depreciating. And so here's the formula: A equals P E to the RT. All right, did everyone get the formula down? I'm not trying to rush you. So here we have the principal in an IRA is $2,000 and the interest rate is 6%. Compound it continuously. How much money will there be after 30 years? So using our formula, A equals your principal E to the rate times T. You identify your variables, 2,000, that's my principal. 6%, that's my rate. 30 is my T. And you plug them in. So we end up with A equals 2,000 E to the 0.06 times 30. Okay, and you're going to plug it in the calculator just as so. Oh, you guys can't see my calculator. Can you see my calculator on your screen? Yes, cool. All right, so just as I typed it, I'm going to put it in. So we type in 2,000. And you're to get the E, it is second natural log 0.06 times 30. Put it in the calculator, get your value. What happened to my thingy? I erased it. 2,000 second natural log 0.06 times 30. And we get $12,099.30. So again, we talked about rounding. Since this is money, we don't need 2 decimal places. We actually need 3 decimal places. We need 2 decimal places. When you change it, you just hit enter and it does it. So we have A equals $12,099.29. So over a course of 30 years, this $2,000 investment grows by $10,099.29. It just took it 30 years to get there. Only 30. All right. So next word problem. Sometimes after a patient takes a drug, the amount of medication A in the bloodstream can be modeled by A equals A sub 0 or A naught, E to the negative RT, where A naught, A sub 0 is the initial concentration in milligrams per R, is the hourly percentage decrease in decimal form of the drug in the bloodstream, and T is the elapsed time in hours. Suppose that a drug's concentration initially is 2 milligrams per liter, and the rate is equal to 2/10. Find the drug concentration after 3.5 hours. So taking what we have, we know that our initial is 2. So this is our A sub 0, right? And they clearly give us our rate. The thing is, because it's declining, this is actually R is, well, yeah, it's already given us in decimal. Never mind. And it's in the formula. It's going to be declining. And then it told us our time here. So this is the T. So we plug in all the variables. So we have A equals 2 E to the negative 0.2 times 3.5. So approximately, what would be the concentration of the drug? Anybody with a calculator, or do I need to pull mine back up? Remember, if you're not practicing using your TI-83s and TI-84s when it comes to the quizzes and tests, and you don't feel comfortable with it, or you don't know how to use the device, it's on you. Thank you. So approximately 0.99. And what does this 0.99 represent? That is milligrams per liter, right? We're going to make sure we label it milli per liter. I should write the grams. So that's the concentration that's left. Here it's asking, when did the drug concentration reach 1.5 milligrams per liter? So now we are working backwards. We're trying to find the time. So for this problem, it wants us to find time. So we know that we're at 1.5. We know that we have 2e to the negative 0.2, but we don't know what t is. Okay, we're going to talk about finding this in the calculator. So finding this in the calculator, we let this be our y1, and this side is going to be our y2. Instead of t, we're going to use x. Are we good? So we're putting this in as y1, and we're putting this in as y2, and instead of t, we're going to use x. So I'm going to go to y equals. I'm going to type in 1.5 for y1. Then I'm going to type in 2 second natural log e to the negative 0.2. And instead of t, I'm going to use x. Good? All right. And then I'm going to hit enter to make sure it's all good. And I'm going to go to my graph. When I go to the graph, I'm looking at what point do they intersect at. That point of intersection is going to help me find my t. So second, trace, intersect. So that's my point of intersection. I'm going to click on it. And you're just going to go, it says the first curve, yes. Second curve, yes. You want me to guess? Yes, I do. And it tells me that my intersection is at 1.44. So therefore, at what time or how many hours have passed by? So we know T equals 1.44 hours. How do you feel about doing that? Questions about using the calculator to work backwards? Okay. Let's look at another problem. So we have here the table lists the concentration in a sample of E. coli for bacteria B in billions per liter after X hours. So at 0, it has 0.5, 3 hours, 6.2, 5 hours, 33.3, 8 hours, 414. Okay. Find the values for C and A so that we can create a model. So remember, to find the value of C, that's your initial, right? That's your f of 0. So C equals f of 0. And what is f of 0? 0.5. So C is done, right? To find our A, we can use any value because we know our C. We can use any X and Y to solve for A. Let's use, what will we use? We'll do 5 and 33. So we're going to use 5 and 33.3. This is my X, this is my Y. And I'm plugging into what I know. So I have an X, I have a Y, and I have a C. So that all that leaves me to do is to solve for my A. So we have 33.3 equals 0.5 times A to the 5. Okay, so I need to get the variable by itself. What's the first thing I'm going to do to get the variable by itself? Divide. Divide by 0.5. When you're dividing by a half, that means you're doubling, right? So I'm just doubling 33.3, which makes this into, which equals A to the 5th. Now I need to find the 5th root of this. So to find the 5th root of this, remember in the calculator, I'm going to have to put 66.6 to the 1/5. That's what my A is. So I'm typing in 66.6 to the 1/5 to find my value of my A. I'm going to go to my calculator. And I'm going to type in 66.6. And I'm looking for the 5th root. So I write it as to the 1/5. And I get 2 and 32 approximately. It doesn't tell me to round to anything else, so I'm going to round to the nearest hundredths. So now we know the value of A, and A is approximately 2 and 32 hundredths. So therefore, my function that represents, that models this, equals 0.5 times 2 to the 32 x to the third x power. And now I can solve anything they ask me, right? So as you can see in B, they're asking me estimate the bacteria concentration after 6.2 hours. So now I'm looking for F of 6.2. So that means I have 0.5 times 2.32 to the 6.2. Go to my calculator. I wish my calculator would just stay on the screen, but it doesn't. 0.5, 2.32 to the 6.2. Hit enter, and I get 92.26. What did I just say? 92.26 billions per liter. All right, what are your questions, comments, concerns? So in your notes, I tried to make sure I give you all possible examples of things you may deal with when it comes to exponential problems. The next one here, we have doubling in half-life. So when you're doubling in half-life, doubling time, the amount of it takes for a quantity to double. And half-life means the amount it takes for it to be cut in half, right? And so it changes. So this is our formula for half-life. So your A is your final amount, your A sub 0, your A naught is your initial amount. The 1/2 lets us know that this is the split factor after the half-life. And then notice that the power is time over the half-life. Okay. So we're going to talk about how does it look. Initially, a link on Facebook has had no hits. So 100% of its hits are yet to occur. Make sense? So it wants us to write an exponential function f that gives the percentage of engagement yet to occur on a typical Facebook link if its half-life is 8 hours. Estimate this percentage after 4 hours. So first thing we know is that we're looking at, what was the half-life formula? I just had a blank. A equals A sub 1/2 T over my half-life, right? Yeah, I think that's what I wrote. And so we're starting off with initial. And so in this case, initially we're at 100%, right? So our A sub 0 equals 100. I'm going to put f of x here. Okay. And then we find our half-life. And our half-life is 8, right? So H equals 8. Are we in agreement? So we plugged everything, our initial, our H, and now we continue. Instead of T, I need to use I guess I can put T here. That doesn't look like a T. Make it look better. All right, so estimate the percentage after 4 hours. So we're now looking for f of 4, right? So I have 100, 1/2, 4 over 8. And that gives me 1/2 to the half power. I'm going to go back to my calculator. I'm going to type in 100, 100 parentheses, 1/2 to the 1/2. Is it okay that I write that? I just went ahead and reduced 4/8 to 1/2. Hit enter, and what is my engagement percentage now? Is at 70.71%. Okay, that's how half-life works. Identify the half-life, identify the initial, bam. Questions about half-life? So the beauty about exponential is that it's formulas, and they're pretty straightforward. You just have to read and pull the information and plug in where it goes. Questions, comments, concerns? All right, then that